Hey guys, what's up? How's it going? This is Akhil, and in this video I'm going to tell you how to use heaps to solve this particular question. Let's jump right into it. Okay, this is last stone weight and we have a collection of stones. So they give an array of stone weights and everything is of a positive integer weight. Okay, so uh, we had to choose two heaviest stones out of them, and we have to smash them based on condition. If the weight of x is equal to the weight of y, then we have to destroy both the stones. Else then we have to destroy x and the weight of y has to be reduced by x. All right, so the identification of correct data structure for this question plays a major role in solving this question very quickly and efficiently. So you have to constantly be taking up two maximum values out of the present values, and then again and again we have to be taking that. So using a heap is a very efficient data structure. Hence, if you don't know what a heap is a binary tree. It can be represented in an array, but it is a binary tree in which the root is greater than all of the children, or 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 it can be a min heap as well. So it has to be, the root has to be the minimum out of all the children. It has to be the smallest value when compared to its children. All right, so when we are popping the root of it, and then we are making these operations, right? So when you pop from a min heap, you are taking the most minimum value. You are taking the least value. Or if you pop from a max heap, you are taking the maximum value. All right, so we have something called, we are going to solve this question using Python, which is very easier to solve. So we have a module called as heap which allows us to do all these operations in just one statement. All right, so we have a heap queue supports a minimum heap. That means you can take the minimum values out of it. So we want a max heap here, since we want to retrieve the maximum two values out of the heap. All right, so we take a minimum heap. You can use a you can get the simulation of a max heap using a min heap as well, just by multiplying all of the values by 1, just like this. Stones is equal to stones of I into -1 for I in range length of stones, right? And so done, all of the elements are multiplied by -1, and what we have to do here is we have to heapify all of these elements, right? So we have an array of stones and we have to heapify them. We have to form the heap structure. So we use heap dot heapify of stones, and that's it. We just do this. So we got the heap here. So this is a minimum heap, but since we have all of them multiplied by -1, so we can retrieve all the elements in reverse order and just multiply by -1 when we have to use them, right? So so if you observe, at the end, if there is one stone left, return the weight of the stone or else 0, right? So while the length of the stones is greater than 1, what we have to do is x is equal to stones, heap cube dot heap pop of stones, and that's it. So we have to multiply this by -1, and y is equal to heap cube dot heap pop of stones and to -1. All right, and so we got the x and y. If x and y are equal, we just have to smash them. Smashing them just means that we have to take them out of the array, as I mentioned here. So when we smash this, a few elements have disappeared from this array, right? So two elements have been disappeared from this array. So we just leave them. If we have x not equal to y, we just have to reduce the weight of y by x. So that means we just push another element of weight y minus x into the heap. That's easy, right? So if x is not equal to y, what we have to do is just push it. We push stones, and we just push this. I mean, what we push y minus x, right? So all right. So if there is something, we just have to return that if you dot if pop of stones, or I mean, we just have to multiply it by minus 1 since we had done it at the beginning, else return 0, right? Yes, this is an accepted solution, and so I think you have understood this. If you don't know what is heap, I highly recommend you to check the things in the description below and have a few readings on that. Heap is nothing but just a binary tree where the root node is greater than all the children, or it can be less than both the children. In either way, one is called a max heap and the other is called as a min heap. And max heap, we just pop off the elements, and this occurs in a very efficient way since the time complexity of removing all these elements is very low compared to operations on a simple array. And that's it, guys. If you have liked this video, give it a thumbs up, subscribe. Thank you.